Okay, so you start the streaming now. Go to the channel. Can you see there the streaming? Okay. So we have to see what in the polynomial. How is the clarity of the video? Okay, no? You can see the board? Okay. Voice is clear, no? Now. So in the polynomials, what is the standard format of the polynomial of cubic or quadratic? Suppose quadratic. Okay, quadratic we will do quadratic polynomial. Tell me the standard form. Can you tell the standard form? Ax square plus bx plus c. Generally this way we are writing. Is it matching the voice and action or mismatching? Matching, no? It's matching properly, no? Okay. So this is the quadratic polynomial, no? Ax square plus bx plus c, standard form, isn't it? So in this, what is a? This is called as coefficient of x square. Okay. In this b, what is b? Coefficient of x. Okay. And what is c? This is called as constant. Okay. If we have cubic polynomial, then cubic polynomial means the degree will be 3. So the standard form is x cube plus bx square plus cx plus d. This is the standard form of the cubic polynomial, ax cube plus bx square plus cx plus d. Okay. In this case, a will be what? The coefficient of x cube. Okay. B will be the coefficient of x square. C will be the coefficient of x, and d will be the constant, isn't it? So see, here the coefficient of x square was a, here the coefficient of x square is not a. Okay. Can you see that? So don't get confused in that. Okay. Is it quadratic or cubic? Accordingly, we have to see. Whatever is in multiplication with x square, that will be called as the coefficient of x square. Whatever is in multiplication with x cube, that will be called as coefficient of x cube along with its sign. Okay, what is the sign here? Plus a, isn't it? So we have to be careful while seeing the coefficient. We have to include the signs also. Okay. Now, next is what? The zero. What do we mean by zero of the polynomial? Zero of the polynomial. We'll make the complete value 0. Then we will call it as 0 of that particular polynomial. Okay. So suppose we have a quadratic polynomial. Suppose we have a quadratic polynomial. Now we will discuss about quadratic. Okay. Quadratic polynomial we have. The standard form is ax square plus bx plus C. Okay. And suppose the 0 of this polynomial is given. What? 0 of the polynomial are, zeros are, suppose alpha and beta. These are the Greek letters representation for the zeros. Okay, means if alpha will be substituted in this, then the complete value will be 0. In place of x, if alpha is substituted, the complete value we will get 0. That's why alpha is 1 of the 0 of this polynomial. Okay. And beta is just like the same, another polynomial, another 0 for this polynomial, that in place of x, when beta will be substituted, again the value will be 0. Okay. So alpha and beta are the zeros of this polynomial. Is it mismatching voice and action? Or okay? Little. Okay. So it's okay now to understand? Okay, fine. So this is the quadratic polynomial, these are the zeros. Fine? So if they are the zeros, then we have to understand that from the 0, there are two things to understand. Okay. One, we have to understand about the factors, of this polynomial. That if these two are the zeros, suppose this alpha is 1 0, if alpha is 1 0, then we can find the factors. From the zeros, how can we move to the factors? From zeros of a polynomial to its factors. Okay. How? That if alpha is one of the zeros, then x minus alpha will be called as one of the factors. Okay. If beta is one of the zeros, then x minus beta will be another factor of the given polynomial. Okay. So we had studied in the last class that if some polynomial, this also becomes one of the polynomial or not. So if this becomes one of the polynomial, then if it is one of the factors, what does it mean? This will completely divide this polynomial or not? Remainder will get 0. So since it is quadratic, how many polynomials, how many zeros we can have? Quadratic degree 2. So depending on the degrees, we have the zeros. If degree is 2, 0 will be 2. Fine. So from the 2 zeros, we got the 2 factors. Is it okay? From the zeros, how to obtain factor you understood? No, just x minus that 0. That will become one of the factors. Means if this polynomial is divided with this x minus alpha, okay, or x minus beta, what will happen? The remainder we will get 0. Clear? So can we write this ax square plus bx plus c, which was the polynomial, can we write it equal to the multiplication of the factors? All the factors, the multiplication of all the factors, x minus alpha into x minus beta. You can write like this. Any problem in understanding this? No, okay, fine. Now what I told, from the zeros, This is zeros, two zeros. From the zeros, we can get two things. What? One is the factor. Okay. Second is relationship between the zeros and the coefficients of x square, x or constant, this or a, b, c. These are the coefficients, isn't it? And constants. So relationship between the zeros and the coefficients. So what the zeros we have assumed? Alpha and beta. Are you here? Listen. So alpha and beta are the zeros. Fine. And we have a relation between this alpha and beta and a, b and c. Okay. So what relations we have? We have two relations. The first one is that sum of the zeros alpha plus beta. If you will add these two zeros, then what will it will be equal to? Minus, do you know that? Minus b by a. Do you know this? Do you know this? Yes, no? Minus b by a. It will be equal to, there is a relationship. Okay, there is a relationship between the zeros and the coefficients a, b and c. Okay. So how they are related to each other? They are related in this way. The first way. What? That if we add alpha and beta, whatever the zeros are there of the quadratic polynomial, if two zeros are there, add the zeros, you will find that value will be equal to minus b by a. If you substitute here b, whatever is its value, and a, whatever is its value, you will see both will be equal. Left hand side and right hand side values will be equal. Okay. So this is one of the relations between the zeros and the coefficients. How is it coming? We will go in deep later, okay? Fine? Because how is it coming is never asked, that question, okay? And for that you have to derive many things and then you have to come to here, okay? It will consume a lot of time also and you may not get it also, and the next thing that it is never asked, okay? So we will go in deep when it will be required, okay? When some questions we will face like that, we will go to them, fine? For time being, you have to understand that there is a relationship between the zeros and the coefficients. It is something like this. You have to keep it in mind, okay? Second is what? Second is alpha into beta. That the product of the two zeros is equal to c by a. It is equal to c by a. That if we multiply these two, then that will be equal to this c constant by a. Fine? This is the relationship. So you have to keep in mind that from the zeros we can find two things. Either we can go to a relation, okay, of the coefficients of the given polynomial, or the second thing we can come to the factors. Fine? Can I erase this? Okay. So the next thing is what? Geometrical representation of this polynomial. or of the zero of the polynomial. Okay, one thing we know that whatever the equation you take, linear, quadratic, cubic, all will be represented on the graph or not? All can be represented on the graph, that we know. We have studied in line something from the what linear equation. Do you remember? That was representing a straight line. So wherever linear equation will be there or linear polynomial, that will represent a straight line. Okay. When there will be quadratic, that will not be straight, that will be curved. Okay. So for curve, we have a particular name for the quadratic curve, that is called as parabola. For the quadratic curve, we have a particular name that is called as parabola. Okay. So that we do not have to worry so much about it. We have to understand what here that each of the polynomial actually can be represented on the graph with some curve. Fine. So on the graph, we know we have 4. This is the Cartesian plane. We know first quadrant, second quadrant, third quadrant, fourth quadrant. We know this. Okay. So from the origin towards the right, this is plus x. No, isn't it? This is this side minus x-axis. No, from 0 we will start -1, -2, -3, -4. Here plus y, and here minus y. We know these things. Yes. So why I do this? This is called as Cartesian plane. Okay. So whatever the polynomial we have, whatever the equations we have, all can be represented on this Cartesian plane or not? Yes, it can be represented. So for the x square, for the quadratic one, we have a curve like parabola, like this one. Okay, or this one. It is represented like this. Sometimes bigger, sometimes smaller, like this. Okay. So all these are called as parabolic curve or parabola. So the thing is what we have to understand here, geometrical representation of the zeros. That is, what was the zeros? What were the zeros for this? We had assumed alpha. No, that was factor. Okay. Zero, simple, alpha and beta. What it is called as beta. It is written like B. Okay, and this one just little more longer. Okay, beta. Alpha. This is alpha ALPHA, and this is beta BET. Okay, alpha beta. So since they are the zeros, how these zeros we can understand from the graph where these zeros will lie. Okay. So suppose we have a quadratic polynomial like this, and suppose we have a parabolic curve like this. Okay. Fine. So we will come to here and here. Wherever the curve, listen. Okay. Wherever the curve is getting intersected by the x-axis. Okay. Wherever the curve is getting intersected by the x-axis, the x-coordinate of those points will be the 0 of the polynomial. This is a polynomial or not? Yes, it is a polynomial only. It has been represented graphically here. Okay. So for this polynomial graph, where the zeros we can find? With zeros we can find wherever it is intersected by the x-axis. Understanding? So we can see here the 2 points. We can see here the 2 points, this and this. Both these points of the curve is getting intersected by the x-axis. Fine. So of this intersecting point, what will be the y-coordinate? Yes. What will be the y-coordinate for this intersecting point? 0. Y-coordinate for this? 0. Okay. Yes. So the x-coordinates are actually the zeros. Okay, alpha and beta. Understanding? Any curve. For example, if I take this curve, suppose. So for this curve, we will be having some polynomial, quadratic polynomial in some form, and then how can we find how many zeros of this polynomial? So we will see how many places that curve is getting intersected by the x-axis. So at 2 places it is getting intersected by the x-axis. It will have how many zeros? 2 zeros. We can even get a parabolic curve like this. How many places it is intersected by the x-axis? 1. Okay. So in that case we will be having the same 2 values of the zeros. Alpha and beta will be same in that case. Of course, we will have 2 zeros because the polynomial is quadratic, but in this case of this polynomial, we will get alpha and beta both equal. Okay? We can even have like this. Okay? Setting 1 point. We can even have the parabolic curve like this. Or like this. So how many zeros in this case? This or this? No zeros. Okay? No zeros for these 2 polynomials. So did you understand what do we mean by actually the zeros, how zeros can be geometrically represented? Yes, for that particular polynomial, whatever will be the curve on the Cartesian plane, wherever it is getting intersected by the x-axis, that point x coordinates will be called as the zeros. Okay? Suppose we have another curve like this. Suppose we have another curve like this. Suppose. So how many zeros for this? This is not a quadratic, okay? This is not a quadratic. This can be cubic or any other form, fine? Anything, some polynomial. But I am asking that how many zeros we can see for this curve. So we will see at how many places it is getting intersected by the x-axis. 1 place, 2nd place, 3rd place. So all these coordinates, x coordinates of these 3 points will be the zeros. So here are 3 zeros. Means it is a cubic polynomial, isn't it? No. Cubic polynomial curve. Fine? So, did you understand what is geometrical representation? Clear, no? So, what is the next one this? Okay, see your exercise 2.1. So in exercise 2.1, see the first question. What is this? The graph y is equal to px are given in 2.10 below, okay, for some polynomial px. Find the number of zeros of px in each case. Means each of the polynomial curves in the question, first, second and third, fourth, fifth, sixth, whatever, is assumed as px. We do not know Px is linear, Px is quadratic, Px is cubic, anything, okay? Does not matter. Fine? Yes, yes. So in this first one, we can see the straight line. Can you see that? So in this, how many zeros can be possible in this case? In this case, how many? At how many places it is getting intersected by? By x-axis or y-axis? How many places? No, the first question I'm asking. First question. Okay. First question, first one. At how many places it is getting intersected by the x-axis? It is not getting intersected by the x-axis, no? So how many zeros? No zero. Say no zero like this, okay? Yes, no zero, fine. So we can not have any zero for this. Okay, in this case. Second case, at how many places it is getting intersected by x? One place. So we can have 1 0 for this. Okay. Sorry. Then the second figure is only getting intersected at one place, no, by the x-axis. We do not have to bother about y-axis intersection. No. Understanding? Only the x-axis intersection, no y-axis intersection. Don't bother about it. Fine. So how many places it is getting intersected by the x-axis? Second one. One place. Okay, one place. So how many zeros? Third one, how many zeros? 1, 2, 3. Okay, good. Then fourth one, how many zeros? 2 zeros. Fifth one, 4 zeros. And then sixth one, 3 zeros. Done. Okay. So this way we can search how many zeros are possible. Okay. Next is relationship that we have seen now. The question. Okay, for the quadratic we have seen, okay. For the cubic,